Alright, sometimes you get two equations that are trying to discuss the same situation, right? So we're going to create functions to solve one variable equations. We're going to write a function here. So if I look at this, right, Susan wants to hire a babysitter for the weekend for her 3 children. She has 2 choices, babysitter A, right, who charges $10 per child and $5 per hour, so f of x equals 5 per hour plus 10 per child, which would be $30 for her, right? And then we've got babysitter B, the child's 15 per child and 2 per hour, so babysitter 2 charges $2 an hour, but her 3 children for $15 apiece would cost $45. That's 3 children at $45. So to find out which cheaper is, write a one variable equation. So 5x plus 30 and 2x plus 45 are one variable equations. Alright. And we're going to solve it. So what we want to do is we find out when they're equal, right? So we say 5x plus 30, this babysitter, when is this babysitter equal to this one? 2x plus 45. So let's bring the variables together. Minus 2x, which gives me 3x plus 30 equals 45. Subtract 30, we get 3x equals 15. Divide by 3, and at x equals 5, so 5 hours is when they would charge the same, right? My guess is, since this one's cheaper per hour, if you're going to go more than 5 hours, get babysitter B. If you're going to go less than 5 hours, get babysitter A. Alright, so this one says this: write a function for each babysitter service, then enter the function in the graphing calculator, which we're just going to put down here and show you the graphing calculators, alright, and find the intersection point, which we do, alright. So we wrote it up there, but f of x, right, f of x equals 5x plus 30, that's our first one. F of x equals 2x plus 45, that's our second one. We're going to do the first one right here. So 30 just for showing up, and then every hour we add $5, right? 45, 50, 55, 60. And this guy right here is 45 just showing up, and then every hour is 2 more, 47, 49, 51, 53, 55, 57. So we can see at 5 hours is where they're going to cross right here on the graph. Alright, we'll keep going. It's kind of fun solving these guys. I like these guys. Alright. Y are the x-coordinate points for the graphs of the equations. F of x equals y1 and g of x equals y2. Oh. Why do they intersect the solutions of f of x, g of x? Right? I'm just going to talk about where they intersect. Right? They intersect at, it was going to be, well, f of 5, and both of them at f of 5, if I'm peeking, are at 55. 55. How would the graph provided by the graphing calculators change to make the graph an accurate representation of this situation? Well, you know what? If you look at that graph, there is one thing kind of strange about this graph, right? It would start here and here. None of this would be true, right? You can't get negative to hours or negative money. So, you know what? We would have to limit, right, domain or x values, domain, to positive numbers. And that's it. Alright, we're going to keep going. Not too many pages. I'm going to skip A because it is using a table and graph to estimate a solution, but it's done for you. I'm going to go to B, which is using a table and graph. Alright? So here we go with B. George is in need of an electrician. Alright? Electrician A is offering services for an initial fee of $125 and $45 an hour. All right. So here we go. $45 per hour plus $125. G of X says he's offering their initial fee of $150 and $38 an hour. So $38 an hour, cheaper per hour, but a higher initial fee. Right? It says about what numbers will the two be charging the same. We'll start plugging in 0, right? So 0 for this first one is 125. And then every time we move up, we add 45. So 170, add 45, 215, add 45, 260 to 305, right? To 350 and to 395. This guy starts at 150, and then we add 38 every time. So 188, was that 226, 264, 302 if we add 38, 340, that one's nice and easy, and so is this one, 378. It says, from the table and the solution must be, well, it looks like they catch up somewhere in here. No, let's look. Somewhere in here, right? This started off higher. 264 is higher than 260, but after the third, somewhere between the third and the fourth, the original one catches up, 305 as opposed to 302. So somewhere between 3 and 4 hours from the graph and the solution, about 3.6 hours. What limitations, if any, exist on the range of the functions? Well, I guess they must be, they're talking money, so range must be limited to hundredths place, right? Hundredths. Because we can only do it on to cents, huh? That's dollars and cents. Like, I don't know, we could go 1.07, right? I'll say example given. 1.32, although it's a lot more expensive than that. Why is using a graph better than using a table to find solution with one variable equations? Well, a graph allows for quick I should have got my estimations. Alright, I can very quickly, if this is my graph, tell that's between 3 and 4. Alright, so here we go. We got one more of these, and I think one more after this and we're done. So we're gonna do this and then hit the last video. I'll try to make the right copies for you guys. Sarah would like to hire a clown. Alright, clown A. Yeah, allowing her services for an initial fee of $111 per hour. So we're going to say f of x equals 11 an hour plus $100 initial fee. Clown B, right? Initial fee of $150 and $8 an hour. So we'll say g of x equals $8 an hour, but the initial fee is $150. Right? Then it says, when will they be the same? We're going to use a table. We can talk about graphing calculus. I need to show how you do this on a graphing calculator in class. So f of x, and let's just do it here. So we'll say f of x here, f of x, and g of x, and we'll start plugging in numbers. Maybe 1, 2, 3. I got a calculator here, so I'm going to skip down to like 16 and 17 to get a full range of hours. So this first one starts at 100, right, and adds 11. So 111, 122. Oh, you know what? I should have started on 0. Let me back this up. I'm going to start on 0. 0 was 100. I numbered that. 1, 2. All right, let's get a good 2 in there, and maybe a 3. 0 was 100. Then the first hour charged 11 more bucks. 111, 122, 133. When I get down to 16, I've already worked it out. 276, 287. G of x was 150. Started at 150, and then went up by 8, so 158. So it's kind of staying ahead for a while. 166. Even at 3 hours at 174. is still pretty far ahead. But the time we get down to 16, it's 178 and 286. So they are equal between 16 and 17 hours. That would have been a huge chart. And I'm going to show you how to do this very quickly on your calculator in class, or on a calculator. I'm going to pause for right now. So we've gone through the first 3 pages, I believe. And we're going to come back and hit 312, and that is very close. We only have one problem on 313. So talk to you very soon.